Oh, it came up. Oh, it's the Maker's Corner again. Gonna be testing some audio, video stuff today, and also starting up a new project. Don't know. It's kind of just come out of thin air. Don't know how long I'll continue it, but it's kind of an experiment. Now then, let's see what we can do here. I wanted to use let's see now. Why is that doing? Okay. Oh, sorry. No, I'm really messing up here. Should be. What's that one? No, that's the camera off. Oh, come on, I need to put the camera. Sorry. Let's see if it'll pop up. Yeah, look at that. It works. Technology is amazing. Now, what I want to do is I want to fix it so that I can actually talk and fiddle with that stuff at the same time. So I'm going to test it now. So what I'm going to do is to switch to this view first. Yeah, okay, then I have the video there. I will somehow figure out how to name the scenes in XSplit, because I can't remember what the quick buttons. No, wait, can one just write it? Oh, sorry, I already know how to do it. My mistake. Oh, well, I'll do that offline. I'm gonna play with it now. Well, then I will at least remember which scene button is. You know what picture video combination is what. Anyway, I was thinking of starting a kind of a new project just to be able to fiddle with some IoT stuff, and also I would like to try some machine learning. And to be able to do that, I was thinking of making a thermal experiment, and it's going to. I was thinking of making it grade-wise more complicated over time, the actual setup. But the basic setup will be this that we have here now in the picture. And now I'm going to switch to another scene. It's this one. Oh, let's see what the... Okay, so here I still have this mic. Okay, so when I switch to the next, when I switch to the picture that only shows these components, then it'll be the camera microphone should pick up the sound, and we're going to test that. And it might turn out that this will not work, so I might be talking to thin air for a while. But let's see if I switch it to that now. Okay, let's see. I'm just going to test my hand. Oh, wait, we need the light. Put the light on. There. I was wondering, wow, picture's all wrong. No, that's the thing, when you do things as a hobbyist, everything is try and straighten things out. Still so twisted. Well, I thought I had this all straight. Oh. Let's see. Lots of fiddling. Oh, this doesn't make sense. Why is it not working? Oh, well, I suppose we'll have to try that then. And the mic should be working. So what we have here is a very simple setup. Now this is, oh, I really have to fix some other. Let's hope this will. Yeah, real amateur. I think I have to fix some of these cables so they won't wobble around so much. So I'll tighten that up a bit. And this is the base. That's not very good. I only have hobby equipment. None of these stands I have are worth anything. But anyway, let's see. So what we have here is going to be a thermal experiment. And here, this here is a 3D printer hot end. I don't know if anybody's seen that, but anyway, basically if you haven't seen a 3D printer hot end before, what you have here is the cold section, and the filament goes through there. And then basically you have the hot end, and then the heater cartridge, which heats this block that melts the plastic as it goes through. But anyway, this is what it's based on, so I'll just throw that out because we're not going to use that. So anyway, here you see we have the heater cartridge, and here we have a temperature measuring thermistor thing. Usually they're PT100s, but I will have to double check that. And then here I was thinking I used this rod here, or pipe. It's an aluminium pipe, and I've adapted a hot end so that I can actually put the heater cartridge in there. And then I'm thinking of connecting this one, the pipe in here. And the first phase of the experiment is to see when we heat this end here, like that. Just going to sit like that. And then of course the thermocoupler is going to be connected. Then I want to see how fast does it heat up how fast does the thermal energy travel through this pipe and comes to the end. And as I said, there's going to be several variations of this experiment. And I won't tell everything right now. So the first setup will be just like that, with the thermocoupler there, and then there'll be another thermocoupler in the end here to measure the temperature at the end of this aluminium rod pipe. And then I want to see how I'm going to make some. I'd like to run it semi-automatic. However, I don't have a power supply that I can regulate using a microcontroller. So that's going to be an interesting thing to solve. I'd like to vary the voltage that I use for the cartridge. I don't want to run it on directly on unregulated 12 volts because then this will just get way too hot. I don't want to run it at 200 degrees. I mean, the idea is to run it like 40, 50 max, so that we can actually have it as a hand experiment and not burning your fingers experiment. Okay, let's back to the main view now. So, now we're back in this view. My computer was warning because of high CPU usage. Maybe it's too much, under too much strains to handle the encoding. Well, we'll see. I'm gonna have to, yeah, I'm going to check watch this video, see if it's worth posting. And if it's somewhat working, then I will post it, or I'll just do what if it's not like completely broken, then I'll probably post it with a comment saying that this is an experiment. But anyway, the first phase is just to assemble that test rod. And as I said, I don't really have a good power supply solution because I would actually like to be able to control the... I was thinking of actually buying another 3D printer control board, because then I could actually pulse width modulate control the heater, but then I think it'll still get too hot, so I think I'd like to run it a bit more like with direct DC and 3 volts or something, because it is a resistive heater, so I could just keep the heat under control, so not heat it up too much. I might have to build a custom regulating circuit, maybe a transistor or something. So, yeah. I mean, I don't know. Maybe one could run. I have an extra 12-volt power supply. I could actually buy a pulse width modulating thyristor. They don't cost anything. The ones used on 3D printers. You don't want to use the control card directly. But then, of course, everything coming from China takes forever, so probably gonna have to try and source it more closer to home. But we'll see. I'm probably over-engineering it. So, but anyway, the idea is that we heat up the end of the rod, and then we see how long, how the heat propagates in the aluminium. And then I want to do some variants of this. And ultimately I want to get into the IoT part, which would be basically controlling the heat production and then measuring different temperatures. I mean, this is just for fun. Just want to have something very isolated and non-useful to play with, because I have quite a lot of IoT equipment. I've got everything, Raspberry Pis and circuit playgrounds and Arduinos and stuff. I'd like to just to get more familiar with those and how to program them in a very simple way. And I just thought I'd make a quick experiment. Okay. That's for now. I'll probably come back and do a short update after I've assembled that and done kind of got also the measurement on the end of the rod, the temperature measurement there, and then I would like to be able to measure the temperature of the block and have that working. I just have to decide what microcontroller I'm going to use, how to get started up with this. Okay, well, see you all later then. I'm going to go and test this video and hope it was somewhat usable.